So also we look at what is first law of thermodynamics. So in this class we will look at what are the applications of first law of thermodynamics. So we have first law of thermodynamics, energy analysis of closed system. You know what is a closed system? So there is no mass transfer, but we can do energy transfer. So first we are going to start the energy analysis of a closed system. Then the first law is usually referred as a law of conservation of energy. That is, energy can neither be created nor destroyed, but rather transformed from one state to another state. So this conservation of energy, law of conservation of energy, is applicable to the first law of thermodynamics. So what we are saying, trying to say is, energy neither be created nor destroyed. So the energy balance is maintained within the system being studied defined boundary. So for various energies associated are then being observed as they crosses the boundaries of the system. So you know what is boundary. So if the energy crosses the boundary, that will be accounted. Then the energy enter will be equal to the energy exit. Right. So this is the energy balance for closed system schematic representation. So for a closed system, the figure show you this is a closed system. We can only transfer energy. We can't transfer the mass. So if you transfer heat energy into the system, you can get the work as an output. So this Z is an elevation. So this V is an velocity. Then this reference plane Z equal to 0. So this Z is the elevation or height, right? So the energy, total energy entering the system minus total energy leaving the system will give you the change in total energy of the system. Will give you the total energy of the system. Or we can write as E in minus E out is equal to delta E system. That is energy in minus energy out is equal to change in energy of the system. So this is the energy equation. So we know the law of conservation of energy. So the energy not be created or not destroyed. Then we know the first law, that is delta U is equal to Q minus W. So we are changing the thermodynamics based on the law of conservation of energy. That is Q net minus W net is equal to delta E system. So according to the classical thermodynamics, we can write the first law as like this. So Q net minus W net is equal to delta E system. Then the total energy of the system, each system is given as, so we can, how will be the total energy of the system. That will be based on the internal energy, that will be based on the kinetic energy, that will be based on the potential energy of the system. So we can write the energy E as U plus K plus E. That is K in the sense the kinetic energy, then P in the sense potential energy. That U is internal energy. Then we can find the change in stored energy for the system as delta E is equal to delta U plus delta KE plus delta P. Delta in the sense change, right? So we can relate the formula delta E is equal to delta U plus delta KE plus delta PE, right? The first law of thermodynamics for closed system then can be written as Q net minus W net, and for delta E system we can substitute the values delta U plus delta KE plus delta P. So we can rewrite this equation. So delta Q net minus delta W net, Q net minus W net is equal to delta E system can be written in this form: Q net minus W net, net in the sense total, equal to delta U, change in internal energy plus change in kinetic energy plus change in potential energy. Then, if the system does not move with the velocity and has no change in elevation, the conservation of energy equation is reduced to. So, if the system is not having velocity, so there is no change in elevation or height, then we can write the equation as Q net minus W net is equal to delta U, that is change in internal energy. So we are neglecting the velocity of the system as 0, then we are neglecting the potential energy. So if velocity is 0, the kinetic energy will be 0. If elevation is 0, the potential energy will be 0. So I hope you know much about what is kinetic energy and potential energy. Yes, you were already studied in physics. So kinetic energy is equal to half mv square, half mv square in physics. So then potential energy will be mg. So here h will be z, elevation. So we can neglect this kinetic energy and potential energy. Then only the internal energy will be available for a thermodynamic system. Then we can write the first law of thermodynamics in the following form as Q net minus W net equal to U2 minus U1 plus V2 minus V1 by 2000, or in some case, if the unit is kg per kilojoule per kg, there will be 2000 in denominator, then 1000 in denominator. If the unit in joule per kg, so we can neglect this one. So we can have V square by 2. Half mv square is written as here. So we can have the equation. So Q net minus W net is equal to U2 minus U1, that is a change in internal energy. Then V2 square minus V1 square by 2000, that is change in kinetic energy, half mv square minus half mv square. Half m V2 square minus half m V1 square is in here. Then we can have change in potential energy as G Z1 Z2 minus Z1 by 1000. So note down the unit, that is kilojoule per kg. So we can rewrite the equation in the unit kilojoule. Then we can neglect the kg. We can take the mass common. Then we can write capital Q net minus capital W net is equal to m into U2 minus U1 plus V2 square minus V1 square divided by 2000 plus G into Z2 minus Z1 by 1000. So unit in kilojoule. So if you want to write this same equation in joules, just we can neglect this 2000, then 1000. Just we can multiply by 1000 in each term. Then we can get the equation in joules. So capital Q in the sense heat transfers, then W in the sense work transfer, then small q and small w. If each terms is written in the term capital letters, that will be a quantity or the property of the system. If the same letter is denoted in small letters, that will be a specific quantity. So if V is denoted in capital letter, that will be a volume. If V is denoted in a small letter, that will be a specific volume. Okay, just don't get confused. If the letter is a capital letter, that will be a property. If the same letter is denoted in small letter, that will be a specific. Right, specific in the sense we can divide by mass. So the volume by mass, capital V by mass will give you the small v. Right. So likewise, we can have all the properties, specific properties. So just understand this. Just small q can be written as capital Q. Then right. So we can rewrite the equation as like this. Then how constant volume process will be. Then we can apply the same equation for constant volume process. For constant volume process, the work done W will be 0. Just recall the thermodynamic processes equations. For constant volume process, W will be 0. So there is no work done. So we can neglect this W. Then we can rewrite the equation. Q naught is equal to M into U2 minus U1 plus V2 squared by V2 squared minus V1 squared by 2000 plus G into Z2 minus Z1 by 1000. Right. So for constant volume process, W will be 0. Then also we can rewrite the equation for constant pressure process. So for constant pressure process, we know PV is equal to W naught will be P into V2 minus V1, P del V. So W will be P into delta V. Right. So we can substitute the W value for constant pressure process in this equation. Then we can expand the equation as Q net minus P delta V equal to M into delta U plus delta V delta kinetic energy plus delta potential energy. Then we can expand this equation as Q net is equal to then M U2 minus U1 plus P V2 minus V1. So this term, notice these terms. So just U2 minus V1 plus P V2 minus V1. So we know the equation for entropy H. H U minus PV. So H is equal to U minus PV. So we can rewrite the equation as U minus PV as H here. So we can get the final equation. U net will be equal to M into H2 minus H1. So just H2 where comes because H is equal to U minus P into V. We will look at what is entropy H later. Just remember this: H is equal to U minus PV. Right. So finally, we can get the equation Q net is equal to M into H2 minus H1. That is change in entropy plus a change in kinetic energy plus change in potential energy. Then this is an example of a closed system. Then closed system, we are providing heat supply to the system. Then we can expect the work done from the system. Right. This is a rigid tank. This is a piston cylinder arrangement. Just we can provide that. We can transfer the heat into or out of the system. Also, we can expect the work done from the system. Then we can move to the problems. Before that, we want to know what is the steam tables. I think this problem is not needed steam table. Yes, we can try to solve this.
Sir.
Yes, ma.
Sir.
Yes.
Sir. Derivation doubt.
Yes. This one.
Derivation, sir.
Yes, yes.
Sir.
Yes, ma.
2000.
Yes, the unit was in kilojoule. The equation for kinetic energy. Kinetic energy equation, kinetic energy is
half mv square.
Half mv square. Yeah. So the half mv square la m மட்டும் கான்ஸ்டன்ட் எல்லா டேர்ம்ல எடுத்துப்போம்.
Okay.
Just half mv square தான் in joules ல வரும் யூனிட். இல்லையா?
Okay.
ஓகேவா? கிலோ ஜூல் எழுதிக்கனால கீழ வந்து 1000 இருக்கு. ஓகேவா? half mv square தான் into 1000 போட்டா அப்படினாக்க divided by 1000 போட்டா அப்படினாக்க we can get the equation. Just m வந்து காமனா வெளிய எடுத்துப்போம். ஓகேவா? Just each and every அதே மாதிரி போட்டு
இன்டர்னல் எனர்ஜில ஆன்சர் போடல.
Yes, internal energy U, that is capital U இருக்கு இல்லையா?
Okay.
capital U அதை வந்து நீ small letter U ல எழுதணும் அப்படின்னாக்க U by M, just small u வந்துச்சு அப்படின்னாக்க capital U divided by M, that is specific internal energy. இங்க U small u தான் இருக்கு இல்லையா, அதுல வந்து just energy மட்டும் தான் இருக்கும். ஓகேவா, that is capital U is equal to small u into mass. ஓகே, just அதுலயும் mass வரும் உனக்கு, then kinetic energy உனக்கு mass வரும். அதே மாதிரி potential energy equation என்னமா, potential energy equation yes சரியா, அதுலயும் உனக்கு mass வரும். just mass உனக்கு காமனா வெளிய எடுத்தோம் அப்படினாக்க we can get this equation. Just we will have another class how to derive this energy equation. Just as of now just note down this energy equation. Okay, so capital letter U தான் அங்க வரணும் நமக்கு. So capital letter U, small letter U எப்படி சேஞ்ச் ஆச்சு அப்படினாக்க just U by mass. Capital U by M will give you small u. Then we can take the M as common outside, then we can have this equation, final equation. Or if you want to neglect this 1000, you want to have the unit joule per kg, then directly we can write this equation without 2000 and 1000. Just remember this equation. This Q net minus W net is equal to change in internal energy minus change in potential kinetic energy plus change in potential energy. Okay. Okay, Amma. Okay. So just you can try to solve this problem. Just read down the problem 2 times. A closed system of mass 2 kg undergoes an adiabatic process. The work done on the system is 30 kilojoule. The velocity of the system changes from 3 meter per second to 15 meter per second. During the process, the elevation of the system increases 45 meters. Determine change in internal energy of the system. Right. So they were given the system is closed system and the mass is and the process is adiabatic process. Then the work done on system is 30 kilojoule. W is 30 kilojoule. Then velocity of the system V1 is equal to 3 meter per second. Then V2 is equal to 15 meter per second. Also, there is increase in Z, that is elevation. So there is a 45 change in 45 meters change in elevation. So we can have Z2 minus Z1 as 45 meters. Then we can use the formula to find the change in internal energy of the system. Just we can just use the formula of energy balance. This Q net minus W net is equal to M into U2 minus U1 plus V2 square minus V1 square by 2000 plus G into Z2 minus Z1 by 1000. Yes, if you apply this formula for this problem, for a closed system, just here we are not providing any heat transfer, so we can neglect the Q. Then we can here work done on the system. So we are taking that 30 kilojoule in minus. Then we can substitute other values. Then minus of minus 30 kilojoule will be 30 equal to mass into, that is mass here is 2 kg. Then only they were provided 2. Then 2 into delta U plus 2 into 15 square. Then V2 square minus 3 square, that is V1 square divided by 2000 plus 2 into M 9.81, you know, oscillation due to gravity. Then G into Z2 minus Z1, that is Z, we know the value for Z2 minus Z1, that is 45 meters. Then we can substitute. Then if you calculate these values, then we are letting delta U alone. Then we can find the delta U value as 14.451 in kilojoule. right? So internal energy. So if you want to avoid if you have the internal energy in joules, we want to convert to kilojoule to substitute here. So we can get the internal energy in the units of kilojoule. Right. This is a basic problem uh, uh, for the use of energy equation for a closed system. Then we can have another example. So, steam at 1100 kilopascal and 92% quality is heated in a rigid container until the pressure is 2000 kilopascal. For a mass of 0.05 kg, calculate the amount of heat supply in kilojoule and the total entropy change. Yes, we need to find is Q, then entropy change S, change in S. Okay, so to solve this problem, we need to understand what is steam table and how can we use this steam table to solve this kind of problems. So just we can look at the steam table. So, the properties of water and steam are given in the tabulated form in the below graphs, below tables. So thermodynamic properties of ordinary water substances is known as properties of the steam tables. Right. So the steam table will be look like this one. So here we are taking this steam table from this source. Yes, if you want to know about the steam table, just you can this link. Then, so these are the terms used in the steam tables. Just achieve specific enthalpy. It will be kilojoule per kg. Then P is small p is pressure. Then small s is specific entropy. Thermal, that is internal energy. Then V is the specific volume. So if each and every symbols will be in small letters, that will be specific properties. Okay, so H enthalpy, S specific entropy, P pressure. So because P can be used in some other properties. So we can have this pressure in small letters. Also we have small u specific internal energy. Then small e specific volume. So also if you see, if the table with the letter C, that is a critical. If the table in small f, that is saturated liquid, and Fg, difference between saturated liquid and dry saturated vapor. So difference between F and G. So F is saturated liquid and G is dry saturated vapor. Fu will give you the difference between the saturated liquid and dry saturated vapor. So why? Because we are looking this. We are using steams or vapors as a working medium for thermodynamic processes. So we need to understand about steam tables and the properties of the steams. Then Tp will denote double point. Then sat in the sense saturated. So this is about steam tables. Then steam table will look like this one. So this is a saturated water and the steam properties with the temperature based. So there will be a temperature in degree Celsius. There will be a pressure saturation in megapascal. Then there will be a volume in meter cube per kg. So F in the sense, Vf. Vf is saturated liquid and Vg is dry saturated vapor. Then Vfg is difference between saturated and dry saturated vapor. So just look at this table. So we can have Vf, Vg, then in the next energy is internal energy. So Uf, Ug, then enthalpy, so Hf, Hg, then Hfg. So if you want to find this Hfg, just we can differentiate these two. So G minus Hf will give you Hfg. So 2500 minus 0 will give you 2500. So if you want to find this one, just we can difference these two, just 2502 minus 4.18 will give you 2498. So just we can the difference Hfg equal to Hg minus Hf. Like that we can have the Sfg, that is Sg minus Sf. Right. So just look at this table. So we can have the properties of the water or saturated water. Saturated in the sense the final attainment. So we can use this steam table to solve problems. So in the problems they will give any of these property. Then with reference to that property, we can take others properties. So just go through this table, and also we need to understand what is interpolation. Just I will Google interpolation. Interpolation. You know, in mathematics, we can use linear interpolation formula. In steam table. Yes. Yes. Can you able to see a link, that is steam tables interpolation YouTube link? You see, we are not going to look at the video. Just we can take this steam table interpolation screenshot. Just what is the enthalpy of the water at 220? Just forgot these numbers. Just we know only the temperature is 220 °C. But in steam table, that at super temperature 220 °C, we don't have the properties. So we can look at that superheated. Just go to the table of superheated steam. Hundred megapascal, that is kilopascal. Here, yes, 0.101 megapascal. So we can have this saturating table. Then temperature is say 220. 220. The properties were 1.5. That is specific volume. Then we can have the internal energy, then entropy, then enthalpy. So there is a 220. Then we can directly take the properties for this. We want to find the enthalpy. So we can take for enthalpy for 220 °C at 0.01 megapascal pressure. Then we can directly take the enthalpy's values as enthalpy here. So 2918.6. 2918.6 approximately here. So, if it, also if there is no values with this 220 means we want to use this interpolation method to get the properties of 220. Just to go through how can we linear interpolation to get the values of steam tables. Just we can use this formula. Just I will give you another interpolation. Yes, take this formula. Just if you just take this formula, this P equal to T3 minus T1 divided by T2 minus T1 into T1 plus T1. So how can we derive this equation? So to solve this interpolation, take this example. So we know the value. We can take the value of specific velocity for 0.1512. We can have these values for a velocity, specific velocity, specific volume 0.15122. There is a specific entropy. There is a specific enthalpy. There is a specific internal energy available. But for the specific volume of 0.1634, we don't have the values in the table. But for the next value 0.17568, we can have the values in the table. Just if you want to find this value, just we can use this formula. That is, U2 will be this one, this value, that is 2945.9 plus the difference between these two values, that is minus 0.15122 minus 0.1634 divided by these, the difference between these two values, that is 0.1634 minus 0.17568 into the difference between these two values, that is first and the last, first and third, that is 31169 minus 2945.9. So this is the interpolation formula. Just go through this one. How can we interpolate? If so, in the table this property is not available, so we can take the interpolation formula to get these values, right? So this is another example. This is an example to solve to interpolate the interpolation formula in the steam tables, right? So in the steam tables there is no values available for this specific volume. So 0.1634 values is not available in the table. Just we can take the previous values and the next values to solve these properties, right? Just if you want to U2, then we can take this interpolation method. Just U2 will be this one plus V1 minus that is V2 minus V1. There is difference, no? So we have to take the higher minus lower. So we can take V2 minus V1 divided by V3 minus V2 into the difference of this. So U3 minus U1. So if you use this formula, then we can get the values for 0.1634 of specific volume. So just if you solve these problems, this kind of problem, we can familiar about how to interpolate. Then just go through this problem 2-3 times, then you can understand. Right, just you can try to solve this problem. So steam at 1100 kilopascal and 92% quality is heated in a rigid container until the pressure is 200 kilopascal. So here the P 100 kilopascal, then the purity is 92%. Then the P2 will be 2000 kilopascal. This we have to have the unit in and megapascal, right? So just take the values. That is P1 is equal to 1100 kilopascal. Then X2 is equal to 0.92. So we can use these properties to get the value of a specific volume by using this formula. So specific volume V1 is equal to Vf1 plus X1 Vfg1. This formula, so specific volume can be found or calculated by using this formula. So we can get these values, that is Vf, then Vfg in steam tables. So we have to look at P1 pressure 1100 kilopascal. So just take the steam table, then go to 1100 kilopascal. Even in megapascal, just 1000. F dg right. So we can have the values. So we can take these values Vf and Vfg by using this table. So we want to parallel to the values of 1100 kilopascal. So here we can take 0.01 kilopascal. So approximately the values will be Vf value will be 0.00113. So 0.001, yeah. So 113. Just we want to interpolate this one, right? Vf value. Then we want Vfg value. So to find the Vfg value, so we can differentiate the value of here the values of Vf and Vg only alone. So to get the Vfg, here Vfg, we have to differentiate this one. So is Vf, Vg minus Vf. We can have the Vfg. Then we can substitute to find the velocity, sorry, volume, specific volume, the state 1. So just go through the table and go through how to interpolate the tables. So we don't have the values at pressure 1100 in the table. So we need to interpolate. Then we can get these values. So we can get these. We can substitute the exact values in this problem, in this equation. That is specific volume 1 is equal to P1 plus X1 into Vfg2. X1 we know the values 0.92. Then we can find the value of a specific volume at state 1. Then like that, we can also find the specific internal energy U1 by using the same formula, UF1 plus X1 into UFG1. Then we can take the same values. So in the table, in the next column, there will be a internal energy. So we can take. So if there is a 110 kilopascal pressure available, then we can directly take the values of specific volume, specific enthalpy, specific entropy, and specific internal energy. If that direct values is not available, we have to interpolate. We have to use the formula for interpolation. Then, so here just keep in mind, or we can take approximately. Right? So in between these values, we have to put the values. So you will get the values in between these two. Okay, so just keep in mind, just of u. Then also we can find the value of S1 by using the same formula, SF1 plus X1 into SFG1. So we can find the we can take values from of S1. So we are finding these U1 and S1 values because in the steam table these two were not available. So we have to find. Also there is a 92% quality. So we have to consider the quality of the working medium. So we have to use this formula. Yes, not only this formula, that is V specific volume is equal to Vf the saturated specific volume, then plus X1, that is percent of quality, then VFG, that is dry saturated specific volume. Just not only this formula, then just go through these problems 3 times, then we can understand how can we use this formula and how can we use the steam table, then how can we interpret the values from the steam tables. So we were found U1 Sn's values and V1's values also. Then we can move to the next question. We can move to the state 2, that is V2. This is a rigid container, so we can have the specific volume equal to constant. So V2 equal to V1 is equal to, so we already found the V1 value, so we can take V2 as V1. Then at P2 were given, so we can take these two values to found the other values U2 and S2. So in the steam table, in the pressure 200 kilopascal. So you want to look at the values of velocity specific volume, that is 0.1634. So before that, we want to compare this specific volume. So if the specific volume is greater than dry saturated volume, then we have to. So just compare this for 2000 kilopascal into steam table 2000. 2000, yes, here. So there is and we have to interpolate. So approximately the value will be to 2 is more, that is 0.001. So here 0.16, so V2 is more, so we have to go to the superheated steam table. So we can directly go to the superheated steam table at 2000 kilopascal. Superheated steam table will be available in the bottom. So this is the superheated steam table, 2000 kilopascal. Yes. So that is a 0.20 megapascal steam table, superheated steam table available. So just you can directly go through this table and we can take these values. That is at the velocity, specific volume 1634. So if the specific volume V2 0.1634 available, then we can directly take, or you have to interpolate 0.1634. That is 0.1634. Here, right? And each the value in meter cube per kg, meter cube per kg, 0.1634. Just try to locate the value of specific volume 0.163 steam table superheated 0.163. Right, we don't have interplay by using these two values. So we have the V1 value. We have to take this V1 value, this, then we value for 0.15122. Then they have the values for 0.17568. So they don't have the values for 0.1634. So they were using interpolation. So they used the interpolation formula to find the U2. Then this is the interpolation formula what we were already discussed. So by using this interpolation formula, they found the U2 value here. So in our table, in the table uploaded in your Teams, these values were not available. Then we can take these two values. That is 0.00106052 divided by. Then this next value will be 0.1634. Then this row will be this one. This row will be this one. Right. So we can interpolate these two values to find the middle value, that is for 0.1634. Okay, this we can use any of the tables. So in this slide, they used any other table. So in that table, the properties available were used to interpolate. So here we have another table, so we can use these values to interpolate. Then we can find the same values. Just try this one. Yes, you can use this table and interpolate. Then we can get the same value. So around it will be around this one, right? 27. Yes. So if you find the interpolation, yes, you will get the values of internal energy U2, specific internal energy U2 value. Like that, we can form the specific enthalpy just values. So you want to understand, you want to practice how to interpolate, then how to use the steam table. Just go through that, go through this problem one or two times, then you can have much more understand. Then, so the thing is, we want to found these values. Just we have the pressure one, and we have the x1, and we have to find these three values. So if these three values were available in steam table, yes, we can directly take from steam table. If these properties were not available, then we have to find these values by using these kind of problems, formulas, right? So we can find V1, U1, then S1. Then we can find V2, U2, and S2. Here V1 is equal to V2. So this is a rigid container. So here V1 is equal to V2. So we want to find the values of our U2 and S2. So then the question is, calculate the amount of heat supply and the total entropy change. So heat supply. So heat supply can be solved by using this formula. The amount of heat supply Q will be mass into change in internal energy. Okay, so we know the value of U2. We found the value of U2. Then we found the value of U1. Then if you substitute these values into this formula, then we can find the value for amount of heat supply into the system. Then also we can use the values to find the change in internal entropy. Right, delta S can be found the change in entropy, that is S2 minus S1. We know the value for S2, and also we know the value for S1. Then we can substitute, find the change in entropy. So these kinds of problem will be in your examination. So just go through the steam tables and this problem once again, then you can have much more understanding. Just we want the values U2, U1, and S2, S1. So because of that, we were using the formulas, right? So this is the answer for that question. The problem will be like that. Then we can move to the next question. Next problem. This also will be the same. Yes. Go through the problem. A rigid tank is divided into two equal parts by a partition. Initially, one side of the tank contains 5 kg water at 200 kilopascal and 25 degrees Celsius. They were given mass, they were given pressure, they were given temperature. On the other side is evacuated. The partition is then removed and the water expands into the entire tank. The water is allowed to exchange heat with the surrounding until the temperature in the tank returns to the initial value of 25 degrees Celsius. Then determine the volume of the tank, the final pressure, the heat transfer of the process. So they were given the values P1, T1. Also they stated T1. So we want to compare this T1. So we want to go to the pressure values at steam. So we have pressure 200 kilopascal. Just to go to the pressure 200 kilopascal and 25 degrees Celsius. Kilopascal. Where it was this value. So in between these two, they have to interpolate. So the value is approximately the temperature value approximately will be first one will be temperature, right? So the temperature will be approximately 200 in the sense 17 to 18, 17 point something values. So this temperature T1 is less than T saturation. So here they already gave the temperature T saturation 25 degrees Celsius. So VV1 will be equal to VF. Okay, so just we have to compare these two values. So if T1 is less than T saturation, then we can directly take the values V1 of VF. So from this table, we can take the value VF. That will be approximately 200 more. Yes. B here. Here. So 0, 1, 1, 3, 18. Right. So approximately this will be 1003. Right. So you can take the V1 value equal to VF at 25 degrees Celsius. So we have to go to saturation VF at 25 degrees Celsius saturation table that will be available in the bottom. That is at pressure 2000 0.2 megapascal. 2.5 megapascal, 2.2 megapascal, 2.8, then here 2 megapascal. And take the values, this one, 25 degrees Celsius. I can take the V1 value as 0.001003 to 1. Here they were taken 0.3, right, approximately. So this is the way to found the value of V1. Then initial volume of reservoir V1, capital V1 will be mass into small v1, that is a specific volume. So we found the specific volume here. Then we can multiply with the mass 5 kg to get the volume of the half reservoir. Right. So they were stated divided into two equal parts. So we are finding the first half. And if you want to total volume, we can multiply with the 2. Then we can get the volume of the total reservoir will be this value. So V1 half reservoir volume will be 0.005 meter cube. And if you multiply with the 2, then we can have the volume 0.01 meter cube. Then the first question solved the volume of the tank. Then the final pressure. Move to the final pressure. We want to go to the state 2. Then we have the values temperature. The temperature will be same, so 25 degrees Celsius. Then for 25 degrees Celsius, we can also found the values. So specific volume. So we know the volume, total volume. If we want to find the specific volume, so we can divide by mass. So volume by mass will give you specific volume. Then we can get these specific volume at state 2. That will be 0.002. Then we can have the values, these values in the steam table. Okay, we can have the steam table at 25 degrees Celsius. So we have to use the stated table. So go to the top. And then for approximately the value V2 002 002. Yes, here we can take the values. So we can compare these two values, these three values. So VF will be greater, will be less than V, that will be less than VC. That is saturated mixture. Then we can have the values. P2 will be P saturation. So horizontal to this B, we can found the P saturation temperature pressure. We can use this one, P saturation. So based on this B, we can found the pressure. So the pressure will be 3.169 kilopascal. So we can compare the heat transfer for this process could be found by using the energy equation. That is Q net minus W net will be equal to mass into delta U. That is change in internal energy plus change in kinetic energy plus change in potential energy. And here there is no work done, so we can neglect. Also there is no velocity, so we can neglect kinetic energy. Also there is no elevation, so we can neglect. So the final term will be Q net equal to M into change in internal energy. So we were found the U2 and U1 values. So to found that we can use these values. So U1 will be U of at 25 degrees Celsius because saturation. So we can directly take the saturation in the last tables. These tables we can use the tables. So in these tables there were U, H and S available. Just we can take these values and we can use these values, and we can found the value of UFG where can be taken in the steam table. Then we can found X2 value. Then this X2 can be used to we have to found the X2 value by using this formula. That is V2 minus VF by VFG. Then this will be 2.3. Then we have to substitute this X value to solve this equation. Then if you substitute the UT values and U1 values in this formula, we can get the value for Q net. This heat supplied to the system can be calculated by M into delta U, that is M into U2 minus U1. So we found the value U2 and we taken the value from steam table for U1. Then we can substitute. Then we can get the values. Q net is equal to 0.25 kilojoule. Here the positive sign indicates heat transfer into the system. Just here we are providing the heat to the system. So there was a positive sign. If there is a heat transfer out of the system, the sign will be negative, right? So this is the use of steam table in thermodynamics. Just if you just solve 1, 2, 3 problems, then you can get some more idea about how to use steam table. So just look at these two problems once again in your home and try to solve with the use of this steam table. Also download this steam table. Then try to locate these values. Try to locate the values of specific volume, specific enthalpy, specific entropy, then specific internal energy by the use of steam tables. Then try to learn how to that value, if the value you want to found is not available in the table, you want to interpolate, right? So just use the tables and solve the problems. Then we can have much more idea about how to use same tables. Right. So just try to solve these kind of problems. I have given the supplementary problems. So just try to solve these two problems from your end. Before that, go look at these two problems. Then we can have the idea. So also try to solve these problems. The only thing is we want to practice how to use these. Right. So just look at the steam tables, then we can solve the problems. Just right, I think viewer gets confused today. So I am stopped here. So we can practice these 5 questions. Then you can upload these questions in our assignment file. Then in the next class, we will look at closed system first law of cycle for a cycle. So there is only one process happens. If the process is cyclic process, the initial state and final state will be the same, but there will be a 2-3 path will be there to get a cycle. Like so this is a cyclic process. So this is a cyclic process. There is 2 processes happened. So process 1, 2 is a isobaric process. Then process 2, 3 is a isothermal compression. Then process 3 to 1 is an isochoric heat transfer. Isochoric process. These 3 processes will give you the cyclic process like this. So process 1 to 2, that is isobaric process. Then 2 to 3, isothermal process. Then 3 to 1 will be isochoric process. Just already we discussed what are the thermodynamic processes available in the previous cases. So to recall that, again we can look at this table and this graph. Let's look at this graph. So this graph 1 will give you the PV diagram of isochoric process. You know what is isochoric process? Constant volume process. This 2, the graph 2 will give you the isobaric process, that is constant pressure process. Then this 3, that is isothermal process. You know, PV is equal to constant. Then this 4 will give you a polytropic process, that is PV power n is equal to constant. Right. Then this 5 will be adiabatic process. Yes. Look at this table. So these tables number 1, 2, 3, 4, 5. In this graph will give you in the comparison of table the first graph is the horizontal line. The vertical line will give you isochoric process. You know that is constant volume process. There V1 is equal to V2, and the ideal gas equation can be written as T1 by T1 is equal to T2 by T2. Right. The constant ideal gas equation will be PV power gamma is equal to constant for polytropic process. N in the sense for polytropic process. Yes, here V is equal to constant, so we can take P is equal to T. So we can take P by T is equal to constant. So P1 by T1 will be P2 by T2. Then the second this horizontal line is a isobaric process. Ma'am, yes, come class. Yes, no fine. Okay, ma'am. இங்கே காலேஜில் இருக்குங்களா மேம்? இங்கே நான் முடிச்சதுக்கப்புறம் கேரளாவில் இல்லை அங்கே வரட்டுங்களா மேம்? சரி நான் வரேன். நான் 5 minutes மேம். 5 minutes வரேன். 3/8 தான் நான் எடுத்துருக்கேன். ஓகே. கௌதம் மற்ற கிளாஸ் என்னம்மா? மேம் கிளாஸா? Ma'am call பண்றாங்க. So we can stop here. Just come, look at this graph and this table. So there is a comparison of all the thermodynamic processes. So there will be a polytropic process. Polytropic in the sense n will be from 1 to infinity. So we can use this formula to have the all thermodynamic processes. So just look at these two slides also, slide number 18 and 19, and we can discuss in the next class. So that's it, today's class. So we can stop here. Then thank you. Have a good day. So if you have any queries, you can wait here, or then else you can leave or hang up.